100,000 to 500,000 patients die every year in the U.S. from preventable medical errors. Preventable is the key word. If one patient dies from something that could be prevented, that should be unacceptable, that should be shameful, and we shouldn't tolerate or accept that. And now we have all the technological tools to make that happen, and we don't do it that way. So that's why, we need to, be, in a way, influencers and preachers of this new wave, in a way, of improving healthcare and educating the next generations. And most of all, healthcare is a basic human right, and we don't treat it that way. We treat it as a political tool, as some economic marker or some development marker, but it's really a basic human right like any other, like education, like freedom. It's a human right, and it has no other definition. It should be treated that way. So, in a way, it's that we have lost in healthcare the human connection, and that's the main problem in healthcare, I think, especially in developed countries. We have lost the human touch in a way. By the way of using more and more technology to do what we do. So the healthcare is less human and less humane as well, and that's a big problem, I think. And technology, like I said before, can really help us change this. And not just technology, because technology can be anything from working wood or stone or basically sending a satellite to the sun. Technology is a spectrum, and it's part of being human. And I think that is how we use the technology and how we think differently, how we innovate, how we really, think, well, the Americans say, outside of the box. So innovating is really important. Disrupting the current standards, the current paradigms. You really have to be a disruptor. You have to be creative, and the creative disruption. There's an author, American author, a cardiologist, Dr. Topol, that wrote a book, The Creative Destruction of Medicine. It's really a phenomenal book for everyone, and it's really about this transformation that is happening and that must happen and continue to happen. And his other book was The Patient Will See You Now, so how the patients need to take charge of their health and drive it, not just have the physician be the director of the process. It's the patient that needs to be. So people say in Venezuela we have a healthy disrespect for authority, so I like that quote, because that's how things need to be. How many of you have ever seen one of this? Like this is actually a real one that I got in eBay a number of years ago, and this like really heavy and only made phone calls. And when you saw someone with this, you say, "Wow, what a dick!" This guy thinks that he needs to be, with his phone all the time, and who needs to have a phone right next to you, 24/7? Look at that now. We have one or two or three phones sometimes, and when you compare this, that only made phone calls, to this little guy who, computer power of a moon lander, you really start thinking, how technology has really exponentially evolved. And the iPhone 10 that has facial recognition, and we use it for silly things like unlocking the phone or making a payment. But imagine how we could have the phone read your facial expression to detect anxiety, or to detect fear, or to detect phobias, or to detect a pain. And pain is a very subjective thing, so we could maybe quantify that by using this technology in a different and a disruptive way. So it's really exciting what's happening. And like I said before, and I don't know if I said it, but I'm from Venezuela originally. That's where I grew up and where my family is and where I trained as a physician. And then I went to the U.S. to train as a surgeon. But I hate revolutions because revolutions badly done don't have good outcomes. But I think that this is an evolution of healthcare, and now is being just faster than it had been in the past. And we have big computers that could do nothing and occupy the whole room, to these little computers that you wear now in your face or in your pocket that can do exponentially more computing equations per second than anything that we could ever dream before. And they get faster and faster and faster and faster and smaller, and also less expensive, which makes the case for something like healthcare, because it's very expensive, so we need to really cut the cost, like any other industry. So like I said before, it's an evolution, and it's also an evolution of even of the species, because we see people with back pain and neck pains because all the time, we have a second idle, and we go to our phones and start doing silly things or important things, but it's rare to see someone who's not on their screen or talking to another human being. So it's really a change of culture in a way. So I always show this picture because I'm from Venezuela, and it's a very rural area, So this is the middle of the Amazon, and they might not have water or toilets or toothbrushes, but they have some way nowadays of providing electricity for an antenna that connects them and allows them to communicate and connect better, with a provider or physician or nurse somewhere else. So doing telemedicine or teleconferencing for healthcare is called telemedicine, and it's a life-saving tool today, and it has been for the last 20 years. We just have better ways of doing telemedicine right now. And where I work in Maine, in the northeast area of the U.S., most of my patients, by the way, speak French because Quebec is right there, and so 2/3 of Maine, they speak French, and the older people don't even speak English. It's kind of funny, but in Maine, it's very rural and very spread, and weather conditions are somewhat not too ideal. So we do telemedicine quite a bit, and we have these big screens that we use in the trauma bay, and we have also portable monitors that are very expensive but very efficient. I can drive a camera from this little cart 100 miles away, and I can drive their camera there on the remote location, manually from my side. So it's really, really exciting. But when we see that we can do this, but then we look at the cost of these devices, and we look at we could do this with a smartphone or with an iPod Touch, even, when those existed. You can do the same telemedicine with a device that costs $200. So it's really thinking differently. And we look at how technology evolves, and we see that in Dubai they have flying taxis today, and this is a reality. It's not a concept anymore. And you see how drones have evolved from taking pictures of people, doing silly things, to now saving lives in Africa. This Zipline is a company based in Silicon Valley, and they're acting in Rwanda to deliver blood with an accuracy of a parking space from, meters and meters up. And they save the life of a woman after partum, after delivering a baby, because there's no blood available. 3-4 hour drive to get blood, and they can deliver it within 15 minutes. 15 minutes from computer call or the app to the delivery of blood and infusion of the blood. So that's pretty remarkable. Again, using technology in a way that we never even thought of before. So in the OR, we use tools like the scalpel and other things, and then we want to add, things like the Hololens, which is like a standalone computer. It's a marvelous machine, and this is already very old. This is like 2 or 3 years old already. And the new one is coming, and it's going to be smaller, lighter, better, cheaper, and so we cannot even think of what we can do with these devices. And now we have a lot of people that is trying to change the way we do things by using devices like this. But it's hard because the OR is all crowded, and it's all, lots of wires and lots of people and lots of equipment, and it's all high adrenaline, and it's not, easy. And you have some person with the loops to augment, some people to put the light on, some people is retracting. So to bring another piece of equipment is sometimes difficult. Sometimes the field of view that we need to operate is very small, or even sometimes microscopic. In the case of neurosurgery, in the case of spinal surgery, in the case of eye surgery, is really difficult. So bringing another tool is sometimes confusing and difficult and complex. In the case of VR and AR and MR, mixed reality, and you all know what that is, more or less, and I know some of my colleagues will talk about that, but we call it the spatial computing, or the fourth computer revolution. The first one was the character mode, the MS mode, and then the graphic interface of Apple and the desktop and the icons, and then the touch interfaces like in the phones and the tablets, and now we have spatial computing. We can do computing in the space with these devices. I can pop up a screen here in the air and manipulate it with gestures, and open another one here, and do a Skype call here, and do an email on this one, and so it's pretty amazing. It's computing in the space, and we can use it for silly stuff, like Pokemon Go, augmented reality. In the U.S., when this started, people on the middle of the streets, at night, doing this, and were hit by cars and stuff because they weren't paying attention. And again, you could do silly things, or you could do things that are completely life-changing. And I don't know if you've seen this movie, the Real Player One. And it's science fiction again, but science fiction is all reality, just a couple decades later or less. So complete immersion by the use of a tool like Oculus or Oculus Go, which is now the detached one, or HTC or Gear, really immersing and changing how the brain perceives what the new reality now is. It's all virtual and digital, but it's real for the brain, and you have incredible accomplishments in this field. And you have things like the Google Cardboard, which is a few years old, and it's $5 in the internet, and you put a phone in there, which we all probably have, and then we put an app which is usually free, and you can immerse yourself in this reality for gaming, for fun, for therapy. So it's really incredible, and you see this more and more Anyone who gets one of these and puts them on, and especially kids, but even older people, you know, grandma, grandpa, you put one of those and they suddenly are in the middle of, you know, Hawaii or something. They all like completely amazed of the power of this to really transport you. And we use it in medicine. We have conference rooms, and the students have, you know, all these little devices, and instead of being in the OR, they can be watching the operation immersed in there. And we have conferences, and everyone gets one of these, and all the conference people, you know, put one of these, and they can be seeing what I'm seeing on mine, and immerse yourselves in the experience that I'm having. You know, it's pretty powerful. Experiential learning, we call it. And people have done surgeries, you know, this way. This is Dr. Shafi Ahmed in the UK. They did an operation in VR, in real time, 360 degrees. And they asked permission of the patient and whatnot, and they filmed it, but didn't record it, just live streaming it. So people anywhere in the world could get one of these little guys, or more advanced ones, or just a phone or a computer, and they could be watching in 360 everything that was happening and listening to it. And they did the statistics afterwards, and they have 55,000 people watch that operation. Imagine that. They brought 55,000 people to the OR, a person to the OR, to learn how an operation is done at one of the top centers in the world. Imagine the power of educating patients, physicians, students, surgeons without expertise on how the surgery should be done. You know, improving the experience. They created a company that's called Medical Realities, which is an app, and basically you learn how to operate with this app. So it's real surgical technique and surgical, you know, theory and surgical content created by surgeons and technical people to improve the way we learn, the way we teach. So it's really, really phenomenal. Medical Realities is available. And like I said before, it's on a evolution. You know, this is in the 60s, the first augmented reality glasses in MIT, so heavy that they had to be suspended, you know, otherwise you couldn't, you know, it was so heavy in the head that it would be, you know, really, really painful. And this is the way it happens right now in a way, but this is from the 60s. Imagine, you know, it's been 40, 50 years now. And devices now are much lighter and better, and this one has, you know, they are still, you know, wired. But now the Oculus Go is wired. It's completely wireless, and you have this similar, very similar experience on the first device, and it's a couple $100, and you have that experience with a device that is completely, it's like a hat. You put it on, and boom, you are there, like completely transported to a different dimension. Have you all done virtual reality at all, or who has not done virtual reality? You all have done virtual reality? Have you put an Oculus Go and been, yeah, so it's amazing. You know, you cannot walk the plank, even though you think, you know that you are in ground, in solid ground. The brain gets strict in a way that is really magical, you know, depending on the content, on the experience. But, you know, people don't dare take the step. You think they're going to fall. So to use this in medicine, you know, to treat, to treat phobias, to treat anxiety. You know, the military, the VA, the Veterans Administration in the U.S. is using this for PTSD, for post-traumatic stress disorder, and soldiers. They revive the experience of the war, and then they heal the soldiers by immersing them again on these problems and guiding them through therapy. So it's really, really powerful. This company here in Belgium, Impulse, is part of Profax. They are measuring how the anxiety levels go up or down when they are immersed in a specific environment, virtual environment, and they imagine they can design a better, you know, a hospital by putting this on and see if you're anxious or nervous. Imagine the operating room design. Imagine the lighting or the colors, or whether you have plants inside an environment or not, or windows or not, to decrease your levels of anxiety. But you can measure this now. So this is the future of, imagine the future of customer, you know, targeting, you know, with something like this. So it could be powerful in many ways, you know, for good or for bad. And we're using this in the OR. We're using it in the OR, and we're using it as a therapeutic tool. In Cedars-Sinai in LA, they use it with patients, and they use it to decrease anxiety and perioperative pain. 53% of the patients in the 2,500 patient study, 53% of the patients decreased their narcotic use and their anxiolytic use. So no drugs, You just put a virtual reality headset and heal them that way, or control their pain or their anxiety. There's a company called Uncomfort, and we have a representative here, and it's a Belgian company, and they actually created a platform that involves specific design of the app to immerse the patient and change the brain in a way that relaxes you and makes you, more calm. So it's really something that is happening everywhere in the world. Applied VR is one of the most advanced companies, probably creating therapies from little kids to older patients, all sorts of therapies in virtual reality. Again, this is very, very powerful. It's a tool, it's a medicine like any other drug can be. So, again, Hollywood, you have Minority Report, a few, 10, 15 years ago, you manipulate reality, digital reality, or Tony Stark's, manipulating. We can do this today. All of this we can do with the tools we have. The HoloLens is this experience. You create holograms in front of you, and you can walk around the hologram looking at this image, and you can interact with this image. It's like magic. But it's not the future, it's not sci-fi, it's real today. Using this for medicine, is really, really, really powerful to do and to teach medicine, like I said before. And this is how we learn anatomy. For example, we go to a cadaver lab. This is obviously hundreds of years old, but it's the same way in a way. And the death teaching the living, the cadavers teaching us how to do anatomy or surgery. Well, it's the same way today. It's a picture of my great-great-grandfather in Venezuela in 1897. He was a surgeon. See how gross that is. And, this is the same way we do it. The cadavers, you go to any advanced university in the world, and they have a cadaver lab, and it's like that, and it smells, and it's awful and ugly and ethically and philosophically and economically, really not acceptable, I think. And we can have, instead of the dead teaching the living, you could have technology teaching the living. Technology by the way of tools like HoloLens, for example, and platforms that are being developed that are amazing. Real, and I'm gonna go through this, but Vive is one of the platforms like Oculus, HTC Vive, and you can create an immersive a fantastic voyage of sorts within the anatomy, to do better, to train before you do. Simulation is a very important part of any discipline that is procedural, like a surgery. We used to say we see one, we do one, and then we teach one. And in a way, it's still like that. You see a few, you do a few, and then you teach the younger guys. This is how surgery happens. But you could do it differently using technology. This is a Case Western Reserve in Ohio, in the US. They created anatomically correct displays, and you can share the content in different HoloLens. And this is 2 years old, this video. You can study anatomy like never before. I've talked to my colleagues, and when we started, we had to do books and drawings and things, and illustrators created content for us. But now we have no excuse to not know anatomy. Inside Heart is, I think it's a free app, or costs like $1. Inside Heart in the HoloLens or in the phone, and then you have this heart that is beating in front of you, and you can submerge yourself inside this heart and learn everything about the heart, for a medical person or for non-medical person. You have immersive touch that immerses you, but also allows you, and they have a platform in there, one of the demos later, that it gives you haptics, the sense of touch in virtual reality. This is very, very powerful. Who does not want their surgeon, to have 500 surgeries in the virtual reality or in the mannequin or the cadaver before they do the surgery in your brain? So it should be pretty logical. And looking at x-rays, for example, we look at images that are 3D, but they're flat screens. So with this, we can look at the 3D reconstruction of the radiologic image and really, really transform the way our brain reads that map, that mental map. And if we put that image in the real patient, like one of my colleagues is going to discuss later, we can really put that image on top of patient, and with millimetric precision nowadays, we should be able to then do procedures in virtual reality, but on the real patient. So it's really, really, again, and I keep saying that, but it's really, really powerful. And there have been operations that have been attempted and done in virtual reality, and it's not there yet, but for diagnosis more than anything else, but it will happen because technology develops exponentially, where we would be able to do this in virtual reality fully. And Animaris, that company, brought it to the phone. iOS or Android, you can have a radiologic image, whatever image, a radiology or CAT scan or MRI on your phone. Imagine that's a dream for anyone who deals with it like a surgeon. or you can have companies that develop real maps of the anatomy, and the surgeon can walk the map, or the patient can walk the map of their own brains and see exactly what the problem is. They finally understand what we surgeons are saying, because we don't explain well, but we could have the patient take the voyage, the brain mapping, it just changes completely, So it's a way to do better surgery. And global access is a problem. 5 billion people don't have access to safe surgery or safe anesthesia. People do get surgeries in tents, in war zones, in areas that are really, really with minimal conditions. Rural medicine is a problem. And rural medicine, the shortage of providers is such that it's really almost a perfect storm brewing in there, because we won't have enough providers. And companies like this one is using augmented reality to bring an expert surgeon's hand from their office to the actual non-expert surgeon's view, so that they can guide them with their fingers in augmented reality in real time, preventing errors and directing the surgery. So the power of this, again, is really untapped yet. And this is the same for robotic surgery. But it takes imagination. It takes imagination to do things differently, And you have, I'm going to go back, and this is a company, a French company, that is doing this for emergency services, where rather than have the emergency service providers on the field, write things down or having to record, they're using HoloLens to input all the information from a wearable device on the patient directly to the HoloLens, and also bring that information to the ER, so that when you get there, the doctor there and the nurses know exactly what to expect, and know your heart rate, or whether you need blood, or whether you need to go to the OR, or whether you need an X-ray of some type. So they are revolutionizing the care of patients on the field by using, again, technologies in a smart fashion. So home care is also, imagine a home care nurse in an older person's home, using this to get data, but also to share the data with a provider in the hospital, preventing this patient to go to the ER unnecessarily, for example, or expediting the transfer to the ER. So it's really, really significant. And this is one of my last slides, but this is allowing virtual reality teleconferencing with avatars, and the avatars can actually manipulate the images. So it's really, really interesting how you can have providers in different parts of the world manipulating in the digital room, in the virtual room, the patient's record, and looking at different information and different radiologic images or whatnot, all conferencing in virtual reality through avatars. And this is the beginning, because you can have haptics now, and the ones of you who watched Real Player One, you have suits that provide you the tactile feedback in virtual reality. And now, you have really companies that are really doing this for good. This is haptX, but you have Sense Glove that it's in the Netherlands, in Delft, and they really transmit the tactile sensation with pretty good accuracy, and it's only the beginning to virtual reality. I was cracking an egg last night in virtual reality. You feel the egg cracking in your hands. So again, it's really, really powerful. And eventually you'll have holograms like this. This is a proof of concept. You have a real person, not an avatar, talking to you in real time and discussing a case. Hundreds, thousands of miles away, improving how we communicate and how we connect. And with the advent of AR Kit or AR Core, you can have all of this technology in your pocket. And Inside Heart created the app for the phone, and you can download it and basically, have this technology and look at the heart wherever you are, in the park, at home, in the OR, and learn about the heart, the anatomy and the physiology in a correct way. And they're doing other organs, the lungs, the brains, and whatnot. But it's really, really interesting what's happening. Technology revolutionizing how we teach and how we do medicine. But not just the technology, it's the smart use of the technology, right? It's the smart use of technology making us better humans, giving us not just healthcare, but humane, humanly better care, and that's what's important. And I'll leave you with this mix of technology, an MRI and maternity, a human, condition of the best ones. Just to give you some thoughts and thinking about this theme. Okay, thank you very much for having me, and it's been a pleasure. All right, let's do this. All right.
Okay, so thank you, Rafael, for this very deep and interesting presentation. We will have questions times before, after all the presentations. So I will introduce you to the next speaker. Sorry, it is Johnny Dwering. He's a MD and a surgeon based in Brussels and working in Brussels, actually in UZ Brussels, which is the university hospital of the University of Brussels. And he specialized in neurosurgery, and he did some research on neuro-oncology and actually dealing with AR and VR technologies in his studies.
It's a bit strange, but it's okay. No, it's fine. Is this on? Is this on? Yeah, okay. Okay. Good evening, everybody. Are you hearing me fine? Yeah. So thank you all for showing up, and thanks to the organizers for having me explain my project and my view on the future of surgery and of healthcare in general. So my name is Johnny Durink. I'm a neurosurgeon. I mainly focus on cranial surgery, but also do spine surgery, as we all do as neurosurgeons. But ever since I began my training as a neurosurgeon, I always had the impression that we could do better. So there's a lot of stuff that you need to learn. You need to gain an intuition of where certain structures are located in the depth. Sometimes you do it by feel, sometimes by experience. But even then, with large experience, there's still some information that you're missing and that you're guessing at. So as an example, a procedure that we often do in neurosurgery is putting in ventricle drains. So in case there's a trauma and an increased intracranial pressure, or a hydrocephalus, for example, then the ventricles swell up, which are the green structures that you see on this slide, and then you want to put a drain in there. So what do the books teach us? They tell us that you need to, in order to put in a drain, you need to make an incision 1 centimeter in front of the coronal suture, which you can palpate, 3 centimeters lateral to the midline, and then that's where you make the incision and your burr hole, and then you target your drain after you've opened the dura, exposing the brain. Then you target your drain in the sagittal plane, like you see there, towards the ear, the tragus of the ear, in the coronal plane towards the medial canthus. So, and then you hopefully end up inside the ventricle. Of course, I always found this a bit strange, that you need to rely on standard landmarks in any patient, even in the presence of anatomy altering pathology, to put in a drain. But once you start doing it, you realize that more often than not you're in the right spot. So you gain a bit of confidence. But even still, when you look at all the numbers, and there's data on this, and you grade the good positioning of a drain from 1 to 4, 1 being perfect positioning, then you see that in practice only 80% of drains are put in the right spot. So again, this is a blind procedure, and this is done in a blind fashion everywhere. And still it's accepted that 80% of drains are only in the right place and 20% are in the wrong place. This is not always life-threatening, of course. You can be a bit off, you don't have to be perfectly inside the ventricle, but even still, grade 3 and 4, which is like 10%, you need to redo this surgery, which is like 1 in 10 patients. So I always felt like this could be improved upon, and it's been confirmed by literature data that shows us that oftentimes it's in the wrong spot. Same goes for pedicle screws. There's a simulation on putting in pedicle screws right there, which is quite interesting. But it's also most often a bit of a blind procedure. There's a lot of methods in order to give you some visual info when you do a fluoroscopy or even 3D fluoroscopy or navigation. But in practice, when you look at all the pedicle screws placed, then grade 0, which means perfect positioning, you only obtain in 60% of pedicle screws that are placed inside the spine. So not perfect numbers either. And when we look at the history of surgical navigation, going from past to present to the future, in the past, then surgical navigation was mainly based on anatomical knowledge. So it means that you studied a lot in the books, you looked at the cadavers, you trained in the cadavers, like Dr. Grossman mentioned. And not only that, and you learn a lot from assisting your masters, but not only that, you also had to expose a lot of normal anatomy. Because if, for example, you have a tumor located, let's say, inside the brain, and you just go straight at it, then you just see tumor. And this is not recognizable. So you need to expose a lot more structure in order to be able to orient yourself, to know where you're actually going. So this means that you need to make larger incisions, larger bone flaps to be able to tackle the pathology. Now, this is advanced, of course, into present-day surgical navigation, where this anatomical knowledge is still of crucial importance, of course. But we also added imaging that we can study in 3D fashion even before the surgery. But what happens in practice is that these images are not correlated to the patient in his positioning in the OR. This means that the surgeon is doing the surgery, and every now and then he looks up at the screen, he makes an image, he has someone scroll through it, because most often you can't scroll through it yourself when you're sterile. You have someone scroll through it, then you make a mental image of the 3D picture, and then you go back to the patient, and then you try to work it all into one big mental image for yourself. So neurosurgery, we're a bit more advanced in that sense that we have a neuro navigation, which means that there's or navigation in general, that we have a correlation between the images that are taken before the surgery and the patient in his positioning in the OR. So as an example here, you can see that the patient is located, sorry, clicked the wrong button, yeah. So the patient is located with the head fixed in a head frame, and this is fixed to a reference frame. So you can see that the reference frame and that the pointing device that I'm holding are equipped with reflecting orbs, and these are seen by the infrared camera of the navigation system, which also contains one or multiple screens and a computer, most often on a trolley. So first, what I did now is, it was sped up in the video, I registered the patient for the system, so you can know where the patient is positioned in the 3D space. And now you can use this pointer device to actually know where you're located and where you're going to go. So this is something, this is current standard practice. It has been for like 20 years, 15, 20 years. It's advancing navigation, and it was revolutionized the way neurosurgery is practiced and orthopedic surgery, but it's not without its limitations. So as I stated, it's quite a bulky device. From any brand, by the way. So there's a computer on a trolley, there's one or multiple screens, there's the camera, etc. Creates an operating room clutter. Like Dr. Grossman said, there's a lot of things going on in the OR. You don't need extra material. So the patient registration procedure was sped up in the video, but in practice, you have to sometimes do it again. It's a bit cumbersome. It tells you the error is too big, etc. So this is cumbersome. But the most important issue with navigation to me is the fact that you're actually holding a device inside the patient's anatomy in your surgical field, and then you're looking up and away towards the screen. So you're looking at something while you're doing something else. So this creates this sort of dissociation interrupts the workflow, can be dangerous also because you can move while you're looking somewhere else. And also, what you're seeing on the screen is really very hard to work inside your brain into a 3D image. It's nearly impossible. You know, radiologists, they do echography, they constantly look at these images, but I can tell you that they do pattern recognition. They don't see the 3D structure, you don't. So, for example, if I were to hold a pointer inside the brain, there's these three upper slices, which are the standard slices. So it's the axial, coronal, and sagittal slices. They don't move according to the position of your pointer, but the lower two ones on the right, they do. So these are trajectory views, which means that if you tilt your pointer, then the image actually changes. And you have two of these. You have one that's going like this, and one that's perpendicular to that one. This is extremely difficult to really know where you are, because as soon as you turn the pointer like this, they switch into one another. So what you're actually doing with this is, I know that if I hold the pointer like this, and if I advance like 2 or 3 centimeters, that this is where I'll end up. But some surgeons don't really fully grasp this, and they think that that image is where they end up, etc. So it's difficult. It's even I use it constantly, use it all the time, and I really cannot, if I use it, I cannot see what I'm going to do. So you look at the device, you know, okay, 2 more centimeters and I'll end up there. And then you go back to your surgical field, and then you have to work everything into a mental image again, huge cognitive load to know where you're going. So this is a huge limitation to me of the Neuro Navigation that, of course, can be easily solved by the solution that we'll be proposing. And then there's the line of sight problem, which means that the camera needs to see everything. It needs to see the pointer and it needs to see the registration star. And oftentimes people or devices are in front of that, so that's also a problem. So I think a very nice comparison for neuronavigation or navigation through patient's anatomy is navigation in the streets and the way that this evolved. So this started out with using road maps, the analogy of anatomy books, where you just use the map and then you try to follow and see where you are while you're looking at the patient. This then evolved into GPSs, rudimentary at first and then more map-based. And these maps always became more and more visually attractive, with actually the ultimate goal to have the driver not pay too much attention to the GPS system itself and just look at the road in front of him. So you can just have a simple glance and know what you're going to do. And not only have the images become a lot more visual, but they added supplementary information. So points of interest, alternative routes, etc. And this is exactly the direction where surgical navigation is headed into. So the next step, and this is already being implemented in certain cars, is for GPSs is heads-up displays, where you just see the information in front of you and you can just keep paying attention to the road. And secondly, of course, augmented reality, where you have the information put on the real world, onto the real world. So to me, this is exactly also where surgical navigation is headed. So actually, my talk is not on VR, which is obvious. It's on AR. I'm sure that you all know the difference between VR and AR, but some people don't. And I think what is a nice quote that I found is this one on pointing what the difference is. And they say that in virtual reality, your screen becomes your world, while in augmented reality, the world is your screen. So you're superposing virtual images onto the real world, like you can see here in this Hololens commercial. So important for the development of this is first the tracking of 6 degrees of freedom, so rotational and translational. This is very important for knowing, so the device knows where it has to place certain things and where it has to keep them. And secondly, the depth sensing of the device. This is what makes all the difference with Google Glass, for example, or any other heads-up display device that doesn't actually have virtual objects interact with the real world, like you see here. So Microsoft HoloLens, which it was touched upon already, I put this in the slide just to be complete. It's a self-contained computer, more processing power, or same processing power as the average laptop, less RAM memory, unfortunately, small battery, field of view is limited, visual processing is not optimal, but it's evolving probably in the Microsoft R&D department, and in 2019 we'll probably have a new one, we hope. So it contains all the sensors that you need. And I had some slides hidden as well, because otherwise the presentation would be too long. But it was on the evolution of augmented reality devices when they first came to be developed, and then when they first became marketed. So marketing, actually the HoloLens is the only one that's made available for developers only, and this was in 2015. But the first AR device was by Vuzix, and it was made in 2011. So, and then there's all the evolution of Magic Leap, for example, that also was created, the company which you probably all know, which was created in 2011, which still hasn't produced anything marketable, but still gained 1.2 billion in funding. So everybody is really eager to see what they'll put to market. But I just stating this to point out that it has only been 7 years, and we've gone from having absolutely nothing and having these really heavy devices in the 60s to having these devices which are really portable, given the time span where they were developed. And probably the next one will be even lighter, even more comfortable, etc. So being aware of all the limitations of Neuro Navigation, I started up a project that was first only at my university, so the Free University of Brussels, the Flemish-speaking one, and my hospital. So together with the engineers on the use of augmented reality for surgical assistance. We call the project SARA. And the goal would be, so we asked for some funding from EMIC, which we'll know of in 2 weeks, together with all these companies. And the goal would be to have the HoloLens to create a heads-up display that displays not only the anatomy of the patient, so all the anatomy that you need, even the deep anatomy, but also any supplementary information like trajectories, angles, etc., like the modern GPSs already do. So they will help you not only showing anatomy, but by giving you guidance. There should be automatic inside-out tracking, which means that the device tracks itself the patient positioning. You don't need any external cameras like you need with the navigation, so no bulky devices needed in the OR. And also, to me, what was very important, which I discussed with the engineers, it should be all very intuitive, ergonomic. So we should have voice control, gesture control, but not difficult gesture control, but actually have it feel like you're touching something and like you're moving it without having to think about it. And the data transfer, so meaning a patient goes into the scan and then goes to the OR, and then you should automatically have all the segmented images, so the 3D images, onto the HoloLens, maybe onto a planning station first, but then onto the HoloLens. So no difficult stuff, having to download images first, work them in a different software, etc. So this to me is also an important step, so this pipeline of working the images from the scan. And this is a proof of concept that we made, so it's in the same setting as the Neuro Navigation, but instead of having to do the registration procedure, you just put on the HoloLens. It recognizes the patient because it has the anatomy from the scan that it did beforehand, and then it can place the anatomy, and every structure is segmented. So now you see the skull. This patient had a previous craniotomy. You can make these structures transparent, so you can see everything. You can walk around it and just look at a skull for fun. But then you can make everything transparent or have disappear some structures and appear certain other structures. I'm making everything transparent now. You can see the brain. If I make the brain transparent, then you can see a brain tumor, where it's located, where its deep parts are, and you can see the ventricle system in blue. So if, for example, you would like to place a drain, you can just do it, and this is also a function that we built in. You place a vector, it's tethered to your hand, virtually tethered to your hand, and you place it. You make everything transparent, and you make sure that you're really inside the ventricle. So right here, we're still putting it inside the ventricle, making it a bit shorter. And then these are some user interface elements that we created. You have the ability to move and tilt the vector in a very intuitive fashion. So I don't know if you ever tried manipulating objects with the HoloLens, and they always go all over the place. So you need to really restrict what you're doing and have it made really clear, so you can very quickly, in seconds, put a virtual ventricle drain in the right spot. So as soon as you've done this, you can make everything opaque again. You can see where you're going through the brain, through the skull, and your surgery is practically finished. So to me, an important remark to make with this is that this is not a gimmick. So I mean, it's a cool gadget to have, and everybody probably thinks, well, it's nice, but okay, we'll just keep doing what we're doing. But it's not, because this will make a huge difference. As I said in the first slide, 80% of drains, and this is just one example of one type of surgery, is put in the wrong spot. 20% of drains is put in the wrong spot. So with this, theoretically, if you have a perfect registration, you can put 100% because you're just seeing where you're going. And if you don't, then it means that, you know, you're blind or something, or there's an error with the registration procedure. So the advantages of this for the patient are really enormous in terms of accuracy, gain, safety, and also there's no more need to expose all the anatomy for exposure, because you have your orientation, because there's the holograms there, and you can see the anatomy without even making an incision. So this is also an advantage for the physicians themselves. So surgery becomes a lot quicker, a lot more visual, and thus intuitive. so the learning curve is decreased, and also there's use cases in all surgical and non-surgical specialties. So any invasive procedure, like anesthesiologists, they do a lot of blocks, they do punctures, they put in vascular accesses. This can all be held by using AR. And there's also a huge advantage for the hospital and society in general, because the cost will be decreased and it will allow for cooperation over long distances. So I put in a few slides just to point out that we're not only producing proofs of concept with the video, but the goal is really to go into the clinic. And what we've achieved until now is that we've done some experiments with this virtual model right there. These are some software developments that we did, but then we did testing on different methods of registration, of tracking of the patient that we developed in part ourselves. So you can see here. And so we had an actual model with some tumors placed inside and some fiduciary markers on the front, which we made a virtual model of, that we then placed and registered to the actual model. So just to tell you how realistic this can be, we had to make the model, the virtual model, blue, because if you had it the same color in white as the actual model, you cannot see the difference, what the actual model is and what the virtual model is. So we did all these registration. I won't go into detail because I think I'm running out of time. But either way, if you look at the summary of this, you can see that using Vuforia, which is an SDK for the HoloLens, we have a mean error of 1.4 millimeters, which means that the tracking of a patient using Vuforia SDK in a specific way that we developed on the HoloLens is accurate to the point of Neuro Navigation, and Neuro Navigation is marketed. So the problem is often with the HoloLens that you register in a certain position, and then when you go to an extreme angle, like 90 degrees from where the patient is positioned or where the model is, that you get an enormous error. So this was 6 millimeters if you turned off the spatial mapping and if you didn't have active mapping. But with Vuforia, because it's constantly updating, because you have some registration cylinder we used, so it's like a reference frame in navigation, this error stays sub-millimeter depending on the angle. So, and then this was another way of pointing it out. So we had people point to where the fiduciary marker to them was located and then measure the distance from the actual fiduciary marker. And you can see that 95% was sub 5 millimeters and 60% sub 2 millimeters error. And this is good. So I think these data, we're working it into a publication, can be used to give to our ethics committee and then ask them to proceed into clinical trials, which we have a full plan of. So in conclusion, I would state that registration using Vuforia optical tracking yields best results with acceptable accuracy for initial clinical testing. So we can move into this stage, hopefully this year. There's still many issues, however, in workflow. So what we use, the segmentation, the holograms, we took our time to do this, but the goal is that you have a patient that comes in, you just have the hologram automatically segmented, transferred to the HoloLens. So this is a full pipeline that needs a lot of work, and this is why we asked the funding with EMEC and in cooperation with all these companies, then started the project. We will hopefully launch in October. But I think as a general conclusion, we can state that with all this technology that's constantly evolving, there's some exciting times ahead. Thank you.
Okay, so thank you, Johnny. Our last speaker for the talks part is Mathieu Egloff from Watt. Mathieu has spent 10 years in the biotech industry, and after that he created the startup Watt to help the biopharma industry. And they created HackoBio, which is a platform using AR and VR to simplify the creation of manufacturing units.
Hello. Hello. Perfect. So, yeah, I will just I will talk like that. It will be okay. So thank you, Marine, thank you, Christophe, to give me the opportunity to talk today. I'm not a surgeon, so my talk will be less scientific, and I will talk about another part of the healthcare, more from the producer's side. So people who produce drugs, so pharmaceutical company, and people who provide machine to the pharmaceutical industry. So I indeed spent 10 years working in this industry, and I'm here today to share with you our expertise to develop web application and VR application for answering the digital transformation and the needs of this company. So before to start, that's today the vision of people. There is a kind of buzzword in this industry. Everyone is talking about digital transformation, having data, artificial intelligence, how we could streamline production, how we can train people virtually or with augmented reality. So a lot of idea and a lot of wish. But I think the reality is more like that. People, when you talk to the people that don't know how to do it, they don't have so many ideas of the technology or what can they do with the technology. And that's today where we are at Watt, and what we want to do is to support these people to use new technology and to find new solution and to design new application. So we are at Watt, a digital agency, and we develop new application for these people. And the story I want to share is based on two examples of our customer, like Bruno Tricoire. So Bruno is director at Sanofi, and Bruno is really a kind of innovator in his domain. So in science, he has developed a lot of new process to produce vaccines or to produce monoclonal antibody, and he made some disrupting choice there. But Bruno doesn't have any idea about virtual reality and augmented reality. And when we first discussed with Bruno, he was really like having no idea of what he can do with this kind of technology. But this guy has a mission today. He has to build the facility of the future at Sanofi. So for him, it's a challenge to understand what he can do and how he can do it. And then we have Nicole. So Nicole Fontourcy, she's working at Paul. So Paul is a company that is selling equipment and machine to Bruno Tricoire. And Nicole is a very energetic woman. She has about 1,000 ideas a minute. She's very enthusiastic about technology and how we can change things. But if you discuss with Nicole, she has a computer that seems to be 10-year old, and she has some trouble to use Skype or Outlook. So again, for her, the challenge is to understand how she can help his customer, so Sanofi, to design the facility of the future and to implement new technology in this new facility. So that's the challenge of these two people that have to design this new facility and that have to implement new technology. And I think it's normal because when you look at one of these software, so used to develop a VR experience, you can understand that they may be a little bit afraid to implement new technology. So a lot of discussion around how to use a digital transformation to simplify your life, to simplify your production, but in Watt, we believe that this digital transformation will be only possible if we make things accessible to everyone. So accessible to everyone, meaning that it needs to be accessible to your grandmother, to your father, and to your brother or sister, So you need to think about tools and technology that are very simple to use, and also connected, open to other systems, so into a same interface. So that's really the key vision we have to develop this application. So you may have this idea, and it's not new. I mean, if you think about your smartphone, that's why they call it smart. Everyone can use it. You have a lot of different applications. You can customize it. It's very simple. So we think that's the way we need to develop a new application for the people. So you can have a good vision, a good idea of what is digital transformation, but I think that's the most important part. It's how you build your application, and for that we really need 3 type of people. The first one, and it's Emily. Emily is working at what? It's a bioengineer. It's a creative bioengineer, making her for having her the possibility to understand the needs of the customer. And I think that's the most important part. You really need to understand what is the trouble, what is the business challenge of your customer, to then develop the right application, develop what is really necessary for your customer. So when Emily has understand what your customer or what the customer is willing to do, she has then to work with a specific guy, the user experience expert, and also in the user interface, to design the most simple and the most intuitive application. We talked in the precedent discussion about human and how it's important to design things for human. We believe also that it's very important to take care about how people will use your application. So you have to make it the most simple as possible. And then definitely you need the last one, so the developer, and there you need really good one to understand the technology and to screen on the markets what kind of technology are available and to make the right choice and decision. So thanks to this vision, thanks to this guy, and based on the demand from the biopharmaceutical industry, we have created this application. So something very simple. On the left side, we have a web application enabling people to create in 3 dimensions an environment, so a space, an industry, a facility. And it's very easy. It's like if you go on IKEA, so the furniture stock company, you can design your kitchen. So here we are even more simple than IKEA. You just drag and drop, and you create in a few clicks your facility. And when you have designed your facility, you are able to enter it with virtual reality. So you can go inside your facility. So behind that, there is a concept. It's called digital twin. We have the same concepts in the healthcare with a digital body. So really making a virtual copy of your existing environment. So people then have a virtual copy of the real facility and the real factory. So then we develop the application, so you can start from the web, but you can also use an offline application on your computer, and your virtual reality to visit your facility, but you can also use augmented reality to manage this facility. So that's the first part, and today we have several users using it, so a biopharmaceutical company. And today we are working to make it smarter. So we are working to connecting our platform to other solutions, so to other applications, to make it more smarter. So today you have your manufacturing environment, so where people are working for real, and there is a lot of application on the cloud to optimize this working environment. It can be simulation, it can be training, it can be monitoring of your environment. So what we want to do is to be the visual interface for all these new applications. So in one visual interface, in one digital twins of your environment, you will be able to manage all these applications, and you will be able to streamline your production. And that's what we are working on. So people will be able to recreate a copy of your existing laboratory. They will be able to simulate airflow. So in this industry, it's very important to be able to have a clean environment, so there is a lot of air flow inside the clean room to be sure that everything is clean. Then you have to really take care of your production, so to optimize your production. And for that, we are working with a Belgian company named ANSYS, AMIA. And AMIA has developed an application to streamline the workflow inside the facility. So we are working with them to connect the two applications, so people will be able to optimize the production flow, so the people flow, but also the material flow and the resource flow. And then we have all what is about monitoring, so how you can control your existing environment. And finally, everything's about training and maintenance. And I think that's today one of the main topics in this industry. So people asking a lot about training. They want the user or the operator to be able to train themselves before going inside a real environment. So in fact, what we listen about physicians that need to be trained before operate, you can apply the same model for someone who will pilot this kind of machine. He has to be trained before to go on the machine. Again, airflow simulation, you better want to have airflow simulation to make sure that you have a well-designed airflow inside your clean room before to build it. Because the cost of building such factory is huge, so it's about 10,000 euro per square meter. So if you make a mistake in a building that is doing 10,000 square meter, you can imagine the cost. And that's what we have today. So here it's people from Paul building a facility. So it needs to be very simple because these two people, they are like sales people or application or scientist people, so they don't know how to manage IT software. So in a few clicks, they are able to design the facility of the customer, and then based on that, they are able to do all the simulation I was talking about. But today it was about virtual reality. So I will show you a quick video of what they are able to do today. So when the people has designed all the facility, they can then use, as I told you, virtual reality to go inside the facility and to look around. And based on that, you can imagine training and so on. So everything I'm talking here, you can imagine to have the same things for an hospital. So you can imagine to train the nurse, or you can imagine to train everyone inside the hospital how to manage things. So here it's a laboratory in the pharmaceutical industry. So they have a very clean environment, and here that's someone wearing a headset, and someone is now looking at all the different systems. So he can walk inside the facility, and he can have ID on all the different equipment, where are the equipment, and he can have so and then people can have information about the different machine and equipment. So yeah, it was really short. So it's really to give you an idea of the basic, and then based on that you can imagine a lot of things. So today, for example, our customer are asking to monitor the path of the operator. So someone is using a VR headset and is walking virtually in the facility, and the people are able to monitor all the paths of these people, and they can then configure in another way the facility to make it more simple and to have lesser distance between the user. So, and it will be the final slide. It's about what these people can do now. So for Sanofi, and they are using the tool, it's a way for them to have these digital twins, and based on that they have optimized the facility layout. So they have a facility that is smaller, and they are really able now to integrate new applications on that. For Nicole, she has now a tool, so she is able to discuss with her customer, and she is able, before the building or before designing the facility, she's able to discuss with the customer and to make the right choice in terms of technology and how to use it. So it's a short presentation, and I'm really happy to talk with you later about that and how to design this application. But definitely, I think the key message is really to make things very simple and to really start from the demand of your customer. Because with digital transformation, with digital technology, you may have hundreds of ideas, and you may want to develop something very sophisticated or very smart. But I think the best is to start step by step, starting with the basic, and then your customer or your user will have new idea, and by iteration you can increase the performance of your application. So thank you.
So thank you, Mathieu. This is now time for questions. So and discussion, of course. So do you maybe have some questions for our speakers? Okay, if you don't, or if you're shy, there's no problem, because we have now like a 20-30 minutes break with some beverages, beers, for instance. And so you can begin the discussion with our speakers during that break. And we will come back in about 20 minutes for the pitches. So thank you.
We gonna start the pitches. I pitch you, you pitch me. I gonna sell you my ID. Come over. I think people are hungry, thirsty for new ideas.
Okay, so time now for the second part of the evening. That will be the pitches. There will be 4 pitches actually, and it will be the same design as just before. So all the pitches at one time, and after that time for questions or for discussions. The first pitch, it will be the company One Bonsai, and the person here to pitch it is Evarest Scofs. And where is Evarest? Okay, good.
Thank you. Yeah, right, so that's good. Okay, can everybody hear me like this? Yeah. Okay, good. So I'm from One Bonsai. Sorry. Online they don't. Okay, so then I do it like this. Perfect. Notice. Okay, yeah. So accidents do happen. So it does happen that you have an accident, and what happens then? You have a problem. You have a break a leg, you break an arm, you break whatever, but you can also have much more than that. You can have a brain injury. You can have any type of rehabilitation needs. So it will take you months, weeks, months, years even to rehabilitate from an accident like that. But this road to recovery, it's actually very, very tough. So it takes time, naturally, but it also can be difficult, it can be painful, and it can be also extremely boring. So you have to, for example, if you have a brain injury, it can take months before you are able to move just your arm again. What do you have to do for that? So you have to do the same kind of exercise, not 1, not 2 times, but 500 times a day. So okay, this is just enormous amount of boring stuff that people need to do, and that is just taking a lot of energy and also motivation from these people. But it's exceedingly important not to give up, because if you do give up halfway your rehabilitation path, you basically lose progress. You basically lose everything. You will not rehabilitate fully or at all. And also they rehabilitate in places like hospitals. Okay, in hospital can be a fun place maybe, but often there's people of all kinds. So people that maybe have lost faith, maybe people that have a worse disease than you, and they don't motivate you necessarily in the correct way to keep on rehabilitating. And why can't you do it yourself? Why isn't it possible to just rehabilitate yourself and have tools at your hand and at your in your house, for example, to really just make your own life? On the other side, you have the healthcare professional. So what's happening with these healthcare professionals? Yeah, basically they have their waiting list. They have people like every day, the whole day filled, and also it takes time to tend to the people. You actually need to nurture them. You need to stand next to them. You need to see what they do. They need to help them, and that's all taking time. So you have a limited amount of patients per day that you can tend to. And then on top of that, you have paperwork. You have the ugly beast that comes every month and every year. Okay, give me the paperwork and show you who you attended to, what you did, and why you did it. And also just the administration, the general administration. It takes time again, and it will reduce the time that they can spend on real patients. So our proposal, okay, yeah, use virtual reality for a purpose. Use virtual reality as a shortcut to do rehabilitation. So we can create engaging environments where people can play in small mini-games, that can motivate and engage them and keep them busy, and really gradually get them to rehabilitate further and further. These mini-games can even be adaptive, so you can add AI to that and adjust them and adjust the difficulty to actually keep people moving on the right path. And next to that, you have technology that becomes more and more ubiquitous. So you have the HTC Vive, you have the Hololens that was discussed earlier on, but you also have motion tracking devices where you see the first version over here, it still had wires. The next version that will be available very soon does not have any wire anymore. It's completely wireless. You can just attach it to your legs, for example, just your arm or one leg, and you can start rehabilitating. It has sub-millimeter accuracy. It is completely self-sufficient and can be attached to any game, any virtual reality game, for example. Next to that, where would you do this? Okay, you can do this at home, naturally, that's possible, but why do it at home if all this technology is available, for example, in the hospital, but also in, for example, location-based VRs, where there's some. In Belgium, for example, you have a few, and there's one sitting in the middle of this room. You have a number of location-based VR, and that means that you have this technology available, for example, 10 or 40 or 4 of the HTC Vive with this technology, where you can start do the rehabilitation and start do these games and send this information directly to the doctors for further analysis and potentially help the people if it's really needed in the hospital. So our proposal is, okay, yeah, we build games for that. We are building games for these small mini games that we can plant in these location-based VRs, add to that some technology like the motion tracking, and really help people rehabilitate faster. So for that we need you basically. So we need to understand, okay, what's the need from the market, what's the need from the professional, or maybe also people that have rehabilitated before or are going to rehabilitate in the future, to see, okay, what's needed and how can we build the system better and faster. So I'm Everest Schoofs from Man Bonsai, and that's the end of this pitch.
Okay, thank you, Everest. Next pitch is on comfort, and the person here to pitch is Julien Tess.
Hi everyone, my name is Julien Tess and I'm marketing manager for Uncomfort. Before starting, I would like to thank LifeTech Brussels, Screen Brussels and Digitizer for giving us a chance to talk here tonight. This is all about Charlotte. Charlotte is 42 years old and she has been diagnosed with breast cancer. Charlotte will suffer from anxiety. It's the beginning of a huge emotional and physical roller coaster for her, with high moments, key moments of anxiety and stress throughout her medical journey. Anxiety will impact Charlotte, of course, but also all the caregivers. Anxiety means an increased cost related to impacted workflow and conditions. Anxiety leads to also an increased level of pain, and pain triggers anxiety, and so on and so forth. Currently, there are 3 different ways to handle anxiety. The first one is just doing nothing, only leaving the patient with this issue. The second option is medication, with all the risk for the health and safety of patients. And the third option is one-on-one intervention, which has been proven to be efficient, but requires training, which is expensive, and most of the time only unilingual. There is one proven evidence-based method that is efficient for reducing anxiety and pain, and that's clinical hypnosis. Clinical hypnosis has been proven by scientific studies, like you can see here from the Lancet, a study showing that it can efficiently reduce anxiety for the patient, and also it can have an impact on the procedure time for the caregivers, with a reduction of 22%. And at Uncomfort, what we do is we standardized clinical hypnosis to have a solution that is benefits for the patient but also for the doctors. So we created the first medical device which combines virtual reality and psychological techniques such as clinical hypnosis. Our solution is used in daily routines, as you can see here, in hospitals. We are used in a very wide range of applications, going from cardiology, orthopedic surgery, radiology, and more generally all the surgeries under local regional anesthesia. We have developed a library of 7 VR modules which are all CE-marked as a software, a medical device, that our environments will be adapted to the patient's language, patient age, and also the clinical situation. So our modules have duration from 2 minutes to 60 minutes to be adapted to the length of the medical intervention. We have currently 8 clinical studies ongoing in major clinical institutions in Belgium, France, and South Korea, with very promising results that you can see here on the left side. That's one of the preliminary results from a study that we have. We see a drastic reduction of post-op pain and anxiety for patients, but also a reduction of the antalgic consumption for patients and the consumption of opioids. And for the hospital, it means also a shortened procedure time, a shorter time spent in the recovery room. And that's also something we observed. If you compare this to other solutions like midazolam, for example, we see that there are less involuntary movements for patients. We have an adequate sedation following 7 criteria identified. And also, everyone is satisfied from the anesthetist, the surgeon, and the patient. Currently, we have hospitals using it, major hospitals using it in Belgium and France. In Belgium, we have, for example, Chirec, Clinique Saint-Jean, UCL, UZA, Maria Midelares, but also hospital in France like Institut Curie, Centre Léon Bérard, CHRU Lille. We started also in Luxembourg. We have more than 3,000 patients who have been helped thanks to our solution. Our objective is, of course, to have this number becoming larger and larger, and trying to reach those 12 million people helped. So that's why I'm looking for potential collaboration, doctors, institutions, and if you want to know more about this, feel free to come at my stand here on the right side, and I will be pleased to talk to you. Thank you.
Okay, thank you, Julien. Next speaker is Flora Coffin, and she will present the company LucidWeb.
Hello, everybody. Can everybody hear me? Okay. Thank you for the introduction, and thank you for the opportunity for us to pitch here. As mentioned, I'm Flora Coffin, Junior Business Developer at LucidWeb. And LucidWeb is a technology company that is focused on bringing VR and AR content to the web, to the browsers. Now, the core of our technology is the WebXR API. Although this might sound like a very new technology, it was already developed in 1994. It took, however, 23 years to become actually a standard, to become actually commercial available. In 2017, the year was there, and it actually came at a very good point in the evolution of VR, let's say, because in 2017, VR had already proven its usability, that it was impactful, etc. However, there were a lot of challenges that still needed to be tackled. For example, when we looked at the healthcare, you had improved patient treatments and medical staff could be educated via this technology. Nevertheless, there was still missing standards and fragmented distribution landscape. And then WebVR came in the scene and actually tackled two of those, and others, of course, tackled those challenges. Now, how did we use this technology? We have developed a distribution platform, the LucidWeb platform, and it wants to make it easy for companies, enterprises, healthcare institutions to distribute VR content. And how does it do it? Because the only thing you have to do as a healthcare institution is actually upload your content to the platform and then just communicate one URL with your clients, with your patients, with your medical staff. Now, for them, it is also very easy, as they do not have to download any application whatsoever. They just simply have to click on the URL you have communicated with them, and that's it. They immediately enter the experience. Now, it is also very easy, as you don't have to worry as an institution of, okay, which device are they using now? Are they using a smartphone or an Oculus Go or whatever device they have at hand? Because the WebXR API adapts itself based on the device the person has in hand. Now again, why we use WebXR and not native applications? The native applications has actually created this distribution, this fragmented distribution market, as you have to have one application per device. And it also implicates a very long and complicated user journey, as you have to go through 7 or 8 steps to actually get into the experience. Whereas WebXR is just one URL for every device, and it has shortened the path to 2 steps. One step, you enter the experience on your desktop, on your smartphone. If you have the possibility to go actually in a VR headset, then you just have to click on the VR icon, which is always there. This would be an example of a hospital using our platform to show multiple experiences, multiple educational experience, patient experience, etc. Now, of course, the question is, how can WebVR add to already the big VR market? Well, the point of WebVR is actually to democratize and simplify the distribution of and accessibility to VR. So with our platform and with WebVR, we actually want to leverage the educational and work experience the medical staff might have with VR, and we also want to leverage the digital experience patients might have with VR. So we want to fully optimize it. Of course, is a big the sector is of course very big, as a lot of you might know. For example, in the EU, the healthcare sector was the second biggest vertical to be funded last year. And when we look at VR specifically, then we see that Goldman Sachs has estimated that it will reach about 5 billion in 2025, which is the #1 enterprise application before even engineering and education, which is kind of huge. And when we look at video, because our platform is really focused on video, PwC have seen that it will outperform VR gaming by 2021. Now, who are we? So Leen Segers is co-founder and CEO. She couldn't be here tonight. She's actually in Italy talking at a conference for 5G, so I'm her replacement. Then we have Fabien Benetou, who is the CTO.